we normally imagine stroke like a brain disease, like something that occurs in the brain. And it's true that there's a lesion that happens in the brain in consequence of a disruption of a blood vessel, or sometimes the interruption of a blood vessel that doesn't bring oxygen to the brain. But what happens in reality is that that damage destroys the connections between our brain and our spinal cord, which is where the circuits that control movement are located. So what we thought was, what if there is a technology that could allow us to amplify those signals that trickle down the lesion that are surviving, and restore the capability of these people to move again. So what we did was that we did a lot of research and found that there are specific spots inside the spinal cord that is located in the neck of the people to restore arm movement, would allow these cells inside the spinal cord to listen again to these weakened signals after the stroke and enable people to move. One thing to say is that we actually utilize technology that is clinically approved already for other use. For example, this spinal cord stimulation is used to treat refractory pain, which is pain that doesn't respond to normal pharmacological treatment. So the technology exists. It's just that we need to approve this new application of this technology and the new location of the implant. Despite this little thing, we still need to go through all the steps that the FDA requires to declare this technology safe and effective. So we need to expand our study to more people, and we've collected $8 million in funding from the National Institute of Health to do the next step in the next 3 years. We're going to expand to 20 people in a more carefully controlled study. And after that, if that's successful, we're going to move to a next study of 200 people, which would finally determine the efficacy and the safety of this technology. And that will probably take between 5 to 7 years.